Hello, Tanya, you there? Okay. So did you solve those equations, balancing equations?
Yeah. The one with the textbook, right?
Yeah.
And just
Hmm.
so the first one is Na plus H2O is equal to NaOH plus H2.
Hmm. The first one is Na plus H2O giving you NaOH plus H2. So left hand side is our reactants and right hand side is our product. So we have to see LHS is equal to RHS. So LHS we have sodium, hydrogen, oxygen, sodium, hydrogen, oxygen. Yes, so how we'll balance it? Sodium is 1 here, hydrogens are
Yeah.
2, oxygen is 1, sodium is 1, oxygen is 1, hydrogen is 3. How will you balance?
Oxygen is also one, right?
Oxygen is, okay, I put it. Hmm, Oxygen, hydrogen. Hmm.
So the first one is um you're supposed to add
Hmm.
2 for the H2O.
Okay, then here it
Two.
becomes 4, here it becomes 2.
Yeah.
Hmm. Still it is not balanced.
So then in NaOH you're supposed to put 2 again.
Hmm. Okay, then sodium is 2 here, then this becomes 2. Hydrogen again becomes 4.
Yeah.
Hmm.
And in here Na in sodium you're supposed to put 2. That's
Yes,
balanced.
it is balanced. So it is 2Na plus 2H2O giving you 2NaOH plus H2. Okay, right. So we'll go for the next one. Next one is Al plus O2 giving you Al2O3. So LHS, RHS, LHS, Al and O, Al and O. Al is 1, oxygen is 2, Al is 2, aluminum, oxygen is 3.
Yeah.
Hmm.
So now you're supposed to put 2 in aluminium.
Hmm.
So it will change into 2
Hmm.
and you'll put 2 to aluminium dioxide
Hmm.
and 3 there. Okay.
Hmm. So 3 to the 6 here, 3 to the 6 here. Right. Good. Okay. So next one, Mg plus H2O giving you MgO plus H2. So LHS and RHS. LHS is Mg, hydrogen, oxygen. RHS is Mg, hydrogen and oxygen. Mg is 1, hydrogen is 2, oxygen is 1. Mg is 1, hydrogen is 2, oxygen is 1. Hmm.
So in Mg, you're supposed to put, not in Mg.
Hmm.
Wait, they're already balanced.
Hmm. It is already balanced. Okay. So next one, HCl plus NaOH, giving you NaCl plus H2O, LHS, RHS, hydrogen, chlorine, sodium, oxygen. Okay, so hydrogens are two, chlorine is one, Na is one, oxygen is one. RHS,
Oh yeah.
Cl is one, hydrogen is two, oxygen is one. So I think this is
Uh,
also balance.
yeah.
So this is also a balanced reaction. So okay, next one, CaCO3 giving you CaO plus CO2, LHS, RHS, CaCO. So 1, 1, 3, Ca, C is 1, calcium is 1, oxygen is 3. So this is also balanced.
So you're supposed to put. Yeah, this is balanced.
This is also balanced. Okay, fine. So we have seen balancing. So after that, you have chemical changes that we have already done. Chemical changes. What are chemical changes? Okay. So how so certain properties which shows the chemical changes we have seen: change in color, formation of gas, evolution or absorption of heat, then formation of a precipitate, then emission of light. Okay. Then we had discussed about rusting. What is rusting? Okay, what is the equation involved? Okay, what is the reaction involved? That is a word reaction and the chemical equation for the rusting. Okay, then what is the measures and precautions taken for to prevent rusting? So that also we have seen. Then browning of fruit, right? That is also done. Browning of fruit.
Yeah.
So browning of fruit, so it is due to the chemical substance
Yeah.
called melanin. Okay, so how you can prevent the fruit from browning? Either by storing the fruit, okay, under water, or you can apply some lime juice over the fruit. Okay, so by rubbing the lime juice over the cut fruits, so you can prevent the fruits from browning. So the browning is it is due to why it turns brown. It is due to the substance called melanin. Okay. Next is reaction between vinegar
Baking soda.
and baking soda. And baking soda. Okay. So what is vinegar? Vinegar is acetic acid.
CH3COOH.
Okay, so vinegar is acetic acid and baking soda is H NaHCO3. Okay, that is you can call it as sodium bicarbonate or sodium hydrogen carbonate.
Hydrogen.
Hydrogen, hydrogen carbonate. So these are the names for your vinegar. So vinegar, what is the formula? CH3COOH, and it is called as acid. And this baking soda, it is NaHCO3. It is called as sodium bicarbonate
Hydrogen.
or sodium hydrogen
Hydrogen
carbonate.
carbonate.
Okay, so we are going to see the reaction. So what they have done, they have taken some vinegar. Okay, they have taken some vinegar in a glass beaker. Okay, so vinegar is taken in a glass beaker. So to this vinegar, so what is this? This is vinegar, that is acetic acid. So for this vinegar, they have added pinch of baking soda. What they have added? Pinch of baking soda. Okay, so what happens? There is evolution of gas. Okay, when you break the soda bottle, how there will be bubbles out, right? So like that, there will be evolution of bubbles, which indicates that there is a chemical change. So this is showing that there is a chemical change which is happening. Okay, so how do we write it? So is reacting vinegar is reacting with baking soda. So this is a word equation. Okay, this is a word equation. So vinegar is reacting with baking soda. Okay, to give you what? To give you sodium acetate. So it is forming a salt, that is sodium acetate plus water plus carbon dioxide. Okay, I'll write it this on the equation form. So why? So evolution of gas. Okay, when there is evolution of gas, so which gas it is? It is nothing but carbon dioxide gas. Okay, so evolution. So whenever you open the soda bottle, so carbon dioxide gas is compressed. Okay, so when you just release it, what will happen? The carbon dioxide gas will release out. So that is the effervescence or the evolution is due to the carbon dioxide gas. So the evolution of carbon dioxide, it is nothing but it is indicating that there is a color change. Okay, so what we have done, we have taken a beaker, we have taken some vinegar. In that vinegar is nothing but acetic acid. Okay, CH3COH. So to that we have added a pinch of baking soda. So the moment you add a pinch of baking soda, there will be evolution of bubbles. So that indicates that a salt is formed. That is sodium acetate is a salt plus water and carbon dioxide gas. So the evolution of gas, okay, it is due to the carbon dioxide which is evolved. So we'll write the reaction now. So this was the word equation in the form of word. Now we'll write in the form of equation. Okay, that is a chemical reaction. So acetic acid
C plus
plus sodium,
NaC
sodium hydrogen carbonate.
hydrogen.
Okay, giving you sodium acetate. So how it is sodium acetate? So how the reaction will take place just here. So CH3CO, this much is negative part. CH3COO minus is the negative part and H plus is a positive part. Na is a positive part. Okay. Na is a positive part and HCO3 is a negative part. So when it breaks, okay, when the reaction is taking place, how it will form? It will form, okay, just a second. So Na will get combined with, okay, Na will get combined with CH3COO. Okay, it will get combined with CH3COO. So this, hmm, like this. So Na, so this positive part is linking with this negative part. So it forms what? Na, sorry,
NaC CH3
CH3COO Na.
Na.
Because this is negative part, this is positive part. So
But
CH3CO.
you've written NaHCO3.
Huh.
What do you write for sodium bicarbonate?
This is only sodium bicarbonate, NaHCO3.
Or you can. So both.
Sodium, sodium bicarbonate, sodium hydrogen carbonate, it is one. So these are the other names for baking soda. Okay, so NaHCO3. So what is happening now? CH3COO, it is getting combined with this CH3COO minus. Okay, so this is the negative part is getting combined with this positive part, that is Na plus. Okay, don't write this plus minus. I'm just showing you. Okay,
Yeah.
so no need to write the plus minus. So CH3CONA, this is a salt. It is a sodium acetate is a salt plus water is H2O plus carbon dioxide is CO2. So this is the chemical reaction how you need to write. So the reaction between acetic acid and sodium hydrogen carbonate, it forms what? It forms a salt, that is sodium acetate plus water and carbon dioxide gases release. So how do we identify the gas? Okay, how do we identify the gas which is involved, which the gas is involved? So what we have to do next is we are going to pass this gas, okay, the gas which is released, we are going to make to pass it into the lime water. Okay, lime water. Lime water is nothing but your calcium hydroxide. Okay, it is calcium
Hydroxy.
hydroxide. You know, old people they put for bitter leaves and eat. What is what do you call that? Tuna.
Ah, yeah.
Huh.
Yeah.
Right. It will be available in the this
Like
tubes and all.
tobacco.
In tobacco. No, it will be white color. Okay, in the
Yeah,
form of in the tubes it will be.
yeah,
So,
but almost like tobacco, right? Like,
yeah.
yeah.
So that is the chuna. Okay, so that they make water. So that will be lime water. So it will be like milk. Okay, milk, like milk color. How the milk appears, right? So the
Yeah.
same color. So when you dissolve, so that will be your lime water. So it is nothing but calcium hydroxide. What is calcium hydroxide? CaOH twice. Okay, CaOH twice. You know OH is what? OH is minus. Ca is what? Plus 2. So how
Yes.
do you write it? Ca because plus 2
CA, CaO brackets of OH twice.
twice, right? Because this will be minus 2. So
Yeah.
plus 2 minus 2 get cancelled. So you have to write only the formula, that is CaOH twice.
Twice.
Okay, like this. So, hmm. So here, so the gas which is liberated, it can be tested. How it can be tested? By passing into lime water, that is calcium hydroxide. So this lime water, when you pass this gas into the lime water, it turns it into cloudy. Okay, it turns it cloudy, or it turns like milky. Okay, milky or cloudy. How the clouds appear like white, right? So it appears, this lime water will be like what you can say, like clear water.
Is
Okay,
they showing that like are they trying to show that like vinegar plus baking soda is equal to lime water?
no. What they are trying to show is, when vinegar, see what they have told. Now vinegar, what they have done, we have taken a beaker, we have taken vinegar.
Yeah.
Okay, to this we had added what? A pinch of baking soda. Okay, pinch of baking soda. The moment we added baking soda, what could we could see? Evolution of
Uh, evolution of
gas.
gas. Okay.
Right. Now we need to, now we don't know which gas it is. Okay, we don't know which gas it is. Now we are finding out which gas it is. So what we have done to know which gas it is, we have passed that gas into lime water. Okay, lime water which was clear. Okay, this is a white like water. This lime water will be like water. So the moment you pass this gas into lime water, it turns it cloudy. Okay, it it turns it into cloudy. So
Yeah.
this indicates that the gas is nothing but it is the gas is carbon dioxide. Okay, gas is carbon dioxide. So this confirms that the gas is carbon dioxide. So this is a test to indicate that the gas which is gas which is produced, okay, when vinegar and the baking soda has reacted, so the gas which is produced is nothing but the carbon dioxide gas. Okay, so the formation of calcium carbonate. So this turns due to calcium carbonate. So what is the reaction? So carbon dioxide gas, it reacts with calcium hydroxide.
See, huh.
Okay,
Gives
giving
you
you
CaCO3
CO3 plus
plus
water.
H2O.
Okay, so this the cloudy color. Okay, the cloudy color of the solution, it is due to this calcium carbonate. Okay, that indicates that the gas is carbon dioxide gas. Okay, so this confirms that the gas is carbon dioxide gas. So this is a chemical reaction which tells you about the chemical change which is happening between the vinegar and baking soda. Understood? Okay. So next is physical change.
Yes. Yeah. We have done physical change like yeah,
Crystallization.
yeah, yeah.
Anyways, I'll just tell this because we have nothing else. Okay, I'll just complete it.
They
Okay.
might do like acid and bases in chemistry.
One more thing. Now, do you have exam now? Recently, when you have exam?
We have next in December.
Next? In
December.
December. Okay, okay. So till December, now this will be, you have a trimester system or how it is?
We have something called MES month end assessments like every month, but
Okay.
it is cancelled due to the Dasara vacations and our annual day.
Hmm. Okay. So after this, you want nutrition in animals
Yeah,
and
acids and bases.
acid and basis chapter,
Mm.
fabric and this that
They won't.
that is not there.
Yeah, that's not bad. Like they are already like done
Acid,
and bases.
acid and basis. Okay. So these two chapters, right?
Yeah.
Hmm. Fine. So I today itself you can just tell your mom to send me the scanned,
Yeah.
okay, scanned pics of these two chapters. Hmm. So that next time it will be very it will be
Tomorrow do you have class or next Monday?
uh directly next Monday.
Okay.
Hmm. Okay. So physical changes. Okay. I'll see if in between if it is required I'll take. Okay. So physical changes. Now you know chemical changes. Okay, if there is certain change in color or there might be certain what formation of gas. So this indicates that there is a chemical change happening. But physical change, can you tell that physical change is happening? Right, by seeing you cannot see, right? So by forming new substances, the changes in which new substances are formed, okay, are called as physical changes. So these changes can only appear due to change in physical properties of the substance, okay, such as change in shape. So if there is a change in shape, suppose you have taken a substance, okay, suppose a substance
Yeah.
you are heating it, okay, it what will it might happen? It either may become larger in size or due to heating it may get compressed, okay. So if there is change in shape, so this indicates that there is a physical change. So whenever the change is happening, okay, if they say that the change is happening, it may only due to the appearance. Okay. So only due to changes in the physical properties of a substance. So first may be change in the shape or size, okay, or the state. Now suppose ice, you have taken ice. Okay, what I have done to the ice, I have heated it. Okay, after heating, what the ice will become? It will turn into liquid. Right, it will turn into liquid. So what you can say that the state has changed. It was solid, it changed into liquid. So the state is changed. So this you can say that there is a physical change. So this tells you that there is a physical change which is happening. So melting of
Physical change, like, can it like be irreversible also?
uh, some can be reversible, some
Like,
cannot.
for example, like formation of steam, it won't the steam won't become water again, right?
No, but if you stop evaporating, okay, if you once you stop evaporation, okay, if you start, if you off the vessel, okay, which is boiling, so again the steam may come back and become liquid, right?
It will.
If it is steam means now suppose I have covered it with a lid, okay, so what will happen? The steam will what it will touch the surface of the lid, okay. Once you off it, so that steam which has collected over the steam, so that will turn into water droplets, okay. So sometimes it will be, but if you just keep it open to the air, so that will be not reversible, it won't come back, the steam it will evaporate, okay. But if you cover it with a lid, so the water it will form the droplets on the lid, again it will be in the form of liquid, like that. So
Yeah.
suppose paper, if you take a paper, okay, I'll tear it. Will it be reversible?
No.
No. So some physical changes are reversible, some are
So like
not.
when candle melts like
Hmm.
wax,
Oh,
it's a
yes.
irreversible change, right? You can't make it back into the normal.
You can make wax.
No, like you can't make it that wax, the candle.
See, once the what happens? Your heated the candle. Okay.
Yeah.
So it will start get melting. But if you stop heating it back, again it will be in its normal position. The wax will get settled down. Okay, it will be in a irregular shape. But again, if you make it liquefy and you put in a what you can say shaper. Okay, if you give again a shape, again it will be back in the shape. Okay,
Yeah.
so
Okay.
at that moment it won't be, but it can be. So melting of wax, formation of steam. Okay, then breaking of glass. Okay, breaking of glass. So once you break the glass, it cannot be reversible. And shredding, tearing of paper. So that is also not. So these are few
So they're
examples of.
telling chemical changes means which we cannot see. Physical changes means what is around us.
Hmm. Yes. Okay, then physical change may be reversible or irreversible. Suppose I have taken sugar and I have dissolved it in a glass of water. Okay, so the sugar will get dissolved in water. Again, what I can get it back? How? If I continuous heat that water, okay, if I evaporate it, so all the water will go into steam. Okay, and the sugar crystals will get settled down at the bottom. Okay, so some process physical changes can be reversible and some will not. Suppose paper. So I can tear the paper, but again I cannot rejoin it. So it is not reversible. So some physical changes are reversible, some
So
reverse,
like
some.
another thing
Mm,
in salt,
mm,
it's a reversible change, right? Because if you like put the salt back to the water,
mm,
if the water evaporates again,
mm.
it will form salt, right?
Yes, yes.
The
Okay.
reversible change.
Yes, you know salt water, right? Now salt water, what they do, they collect it in the form of small pits. Okay, they collect the salt water into some small pits. Okay, and in the sunlight. So due to sunlight, what happens? The water will evaporate. Okay, and you will be left with the small salt crystals. Okay, you will be left with the salt crystal. Now this salt which will be left over after the water is get dissolved, so this will be impure. Okay, this will be impure. Now to purify this salt, we are going to do the crystallization. So this crystallization, I had told you how they do
Yeah,
crystallization.
yeah.
Crystallization, they are going to take the solid.
So
Okay, to this solid, they are going to add a liquid which will
which
dissolve it,
dissolves the thing, yeah.
dissolve the thing. And then what I'm going to do, going to take a filter paper. I'm going to filter it. So whatever the impurity is there, it will get settled down in the filter paper, and you will get a filtrate. So this filtrate, what you have to do, you should not shake it. You just keep it for some time. So after some time, it will get uh, formed into small crystals, which will be like fine needles. Okay, so this will be in the purest form. So this is nothing but crystallization. So whenever you get mm, so okay, so this is the most important what you can say process of purifying any substance, that is crystallization. So very important. So one best example is salt, that is salt formation. So whenever seawater, so that is conversion of seawater into salt. Okay, conversion of sea
The water into
water into salt. So this is also the best examples, as I said. So what they do, they
they put
put
salt
in
pans.
the large open pits, they are called as salt pans. Okay, salt pans. Then due to sun, okay, sunlight, the water gets evaporated and the salt, okay, that will be in the impure form. Then you are going to
They'll put
subject.
it on the sea or will they
Mhm.
the seawater?
It will be collected just side to the bank of the what you can say. Uh,
Ocean.
yeah, it will be like small. It is not near to the sea. Okay, just beside the sea. Okay, there will be small lakes also. So near the lakes also, uh, this salt water will be there. So what they do, just near the lakes, they do small pits and they collect that salt water into that. They dump it, okay, and then due to sun rays, due to sunlight, this water gets evaporated and you'll be left with the small salt crystals. Understood?
Yeah.
So this is crystallization. Okay. Any doubts here in this particular chapter?
No, not a lot of.
Hmm. So what else you want me to do now? Any doubts?
No.
Now for your like monthly assessment, which all exam test you have you said? Now this one, as we have finished one.
Yeah,
Then
like
second.
from June we had MEA 1,
Huh.
July MEA 2, and August we had MEA 3,
Hmm.
and September we had term 1. October we won't be having anything for Dasra holidays. And November we don't, it got cancelled for some, um, like, lot of exams. So,
Hmm.
in December I have midterm.
Okay, for three. So for December till December, what all portion you have then?
Uh, we have 2 chapters for activity, so we won't be having that.
Huh.
We'll be having in chemistry, we'll be having acid, bases, and salts,
Hmm.
and uh, wastewater and management,
Hmm.
and transportation of substances. Rest all are biology.
Transportation of
Um,
substances.
yeah.
Hmm.
Even climate and adaptation, but I thought that was biology.
Which one?
Climate and adaptation.
Now, which is there for biology? Let me know.
We have nutrition in animals and
Nutrition in animals. Hmm.
uh, respiration in organisms.
Respiration in organisms.
Yeah.
Hmm.
Reproduction in plants.
Reproduction in plants.
Like these many chapters were.
In plants.
Yeah.
Hmm. Okay. Can you tell me for physics? So that
Physics, we have. They still can tell us, but I think we'll be having heat and temperature
heat and temperature.
and electric current and its effect.
Electric
Current and its effect.
current and its effect. Okay. And
Yeah,
four.
only that one.
Okay.
We have another one for activity, so I think we won't be having that for midterms.
Okay. Fine. Fine. So, like, I want you to send me on nutrition in animals and acid, bases, and salts. Okay. So next time we'll start with nutrition in animals or acid, bases, and salts.
They're doing nutrition in animals, so I think acid, bases, and salts.
You want acid, bases, and salts,
Yeah,
right? Okay, fine. So I'll start with acid, bases, and salts. Okay.
yeah.
Okay then. So
So
if
should
you,
I send both of them or?
yeah, yeah, you want nutrition in animals me to do, or it is like if it is clear,
First, I want acid and bases.
so that will finish, and then after that we'll see nutrition in animals.
Yeah.
Okay, fine then. Uh, you want anything else you want me to you want to ask?
Um, I was reading through this chapter called acid and bases. Like they
Hmm.
didn't start,
Hmm.
but is a tamarind an acid? A
Now
tamarind.
you know orange.
What?
Orange, fruit
Yeah.
orange. So, okay, just a second. It is nothing. Hmm. Okay, so orange, okay, orange, lemon, uh, milk, okay, then, okay, you said tamarind.
Yeah.
Hmm. So in orange, there is acid called as citric acid.
Okay.
Lemon, citric acid. Milk, okay, to convert milk into curd, there's something called as lactic acid. Okay, in tamarind, there is something called as tartaric acid. So these are acids. So which are the main
Like,
what?
are these acids
No,
harmful for our?
no. You eat orange or no? Is it harmful?
Yeah. No.
You drink lemon juice.
Yeah.
Yeah. So these are a type of acids, okay, which are present in fruits. So these are not hazardous. So which are
Did they
hazardous
tell
acids?
us that too much citric acid may cause gastric?
It may cause it will what you can say, it will cause you acidic problem, right? It will cost you this what gastric problem, right? So it is why when you have more of acid. So if you have more of acid, then you will get acidity. So that will cause your health. It is not hazardous. Hazardous acids are what? Concentrated acids, like concentrated hydrochloric acid, concentrated sulfuric acid, concentrated nitric acid. So these acids, what you cannot, what you can say, you cannot eat them, you cannot drink them. So these are hazardous. Okay, it will burn your throat. Okay, so these are hazardous. You cannot use them. So handling them also is to be handled. You should handle them very carefully. But these acids, they are what you can say, they are the main components. Okay, they are the main components of this fruits. Okay, now tamarind. So why it is like that? So why the taste is what you can say sour like? Okay, why it is that taste? So it is due to this particular ingredient which is there. That is due to tartaric acid. So lemon. Okay, the flavor how it will be. It is due to this acid. So it is just a flavoring agent or it is just the main ingredient. It is not playing any harmful effect on that. Okay.
Yeah.
So there are acids. Okay, there are bases, but it is not that so some of the acids and bases you consume them. Okay. So it is not that always acids and bases are hazardous. Okay,
Yeah.
fine. So you just read once. So next time we can start with acid bases and
Yeah.
salts. Okay. Fine, fine then. So I shall end the session here. Okay. So we'll meet in the next class.
Yeah. Thank you.
Okay. So yes, thank you. Bye.